Hey, let's continue with the next section, 1.5, Intersections, Unions, and Compound Inequalities. In this section, we will work with compound inequalities that consist of two or more inequalities joined by the word and or the word or. We now solve such sentences and find the set of all solutions. And statements. Definition of an intersection. The intersection of two sets A and B is a set of all members that are in common to A and B. We denote the intersection of sets A and set B as the A intersection B. So that little thing that looks like an N, that's called an intersection. And when you're looking for an intersection, you want to look at what they have in common or where they overlap. So you want to look what they have in common. So in this next example, we're being asked to find the intersection of these two sets. Each curly bracket represents a set. So think of this as set A and set B. I want to find the intersection. So I want to compare my two sets of numbers and say, hey, what do they have in common? So we see here that they both have a 2, they have a 3, no 4, no 5. B has a 0, but A doesn't have a 0, or a -1 or a -2. So the only thing they have in common are 2 and 3. So my answer would be the numbers 2 and 3 in little curly brackets. And that's it. That's an intersection. Next definition, conjunction. The next two or more sentences are joined by the word and to make a compound sentence. The new sentence is called a conjunction of the sentences. Note that conjunctions can be abbreviated. So let's say I have two inequalities, such as A is less than B and X is greater than A. I can combine them to be A is less than X, less than B. Notice the X is in the middle. Or what if I have something like B is less than X and X is greater than A? They can be joined together to be B is greater than X greater than A. Moving forward, and intersection. The word and corresponds to intersection, so the symbol intersection, in order for a number to be a solution of a conjunction, it must make each part of the conjunction true. So let's solve and graph. Whenever you have this type of conjunction with inequalities, your answer will be an and statement. You want to look where they have in common, an intersection. Okay, so we have two inequalities, but just like an equation, when you do to one side, you do to the other. In this case, you want to do it to all three sides. So our goal is to get x by itself. Where is x? X is in the middle, but there's other numbers around it. So let's do some work to get x by itself. Let's move the 5. So let's subtract 5. Minus 5, that gives you 0. But you do to one side, you do to all other sides. And what do we have now? 1 minus 5 is -6. Is less than 2x. Is less than 13 minus 5, we get 8. Last piece, let's get x by itself by dividing by 2. But remember, we do to one side, you do to all other sides. -3 divided by 2, I just have the answer. -6 divided by 2 is -3. That's less than x. Less than 8 divided by 2 is 4. And that's our answer. This compound inequality tells us that they overlap strictly in between -3 and 4. That is our answer. But we have to be careful. I have to make sure to use a proper sign because that's a less than equal to. I'm going to use a bracket because here we have less than without equal to. I use the parentheses. One thing to notice is when I have compound inequalities and they have an and, if they're overlapping this something, they're always an x in the middle and our inequality should point to the left. Next definition, empty set or disjoint sets. Sometimes two sets have no elements in common. In such case, we say that the intersection of the two sets is an empty set, denoted by empty curly brackets or a zero with a line through it. Two sets with an empty intersection are said to be disjoint. Alright, so here we have a picture and we see that there's two sets, set A and set B, and they don't overlap at all. They are disjoint. That's what the image is showing. Let's do an example. Let's go ahead and solve the graph. Now notice this one's written differently. Instead of giving us a compound or a conjunction type of statement, it's giving us two statements. But because we have that word and, my answer will be whatever they overlap. Our answer is where they overlap. Okay, let's solve for x. So plus 3, we get 2x is greater than 4, divided by 2, divided by 2. That divides to make 1. We're left with x is greater than 2. Next one, let's solve our next equation. Let's get x by itself, so let's move the 1. Plus 1, plus 1, that makes 0. 2 plus 1 is 3. So we're left with 3x is less than 3. Divide by 3, divide by 3. X is less than 1. Okay, let's graph these two statements. X is greater than 2. I'll use red for that one. X is greater than 2, so that numbers are greater are to the right. And I'm going to use a parentheses because there's no equal to. I'll do the next one in green. X is less than 1, so less than will be towards the left. And there is no equal to, so I'll use a parentheses. That's my answer. Notice that our answer is strictly asking us for where they overlap. We want to and answer, a conjunction answer. Do they overlap? No, they don't. So my answer is the empty set. I want to quickly note the way our problem was presented with the and in between does not indicate that it was going to be an empty set. The and tells us that we want to answer where they overlap. The question can be given as two separate inequalities or as a compound. Both are okay. All right, so quick note, what did you learn from the past two examples? Maybe take a moment to pause the video and write down your thoughts. Next example, we're asked to solve. Whenever you have a compound inequality, it's always and. Okay, so we're looking for an and type of solution given this problem. Let's go ahead and solve. So remember, when you do to one side, do to all sides. In this case, all three sides. Let's solve for x. Let's move the 5. So we have minus 5, that gives us 0. Minus 5, you get negative 2 and 2. So far we have negative 2 is less or equal to negative 2x less than 2. All right, I want to get x by itself, so let's divide by a negative 2. Uh-oh, we have to be careful. I'll draw a little star so I don't forget. When we divide by a negative, remember to change your signs. So I drew a star so I don't forget. That's what I do, so because it's such an easy thing to forget. All right, so we have negative 2 divided by 2, we get negative 1. And I'm going to write greater than or equal to, because I divided by a negative. X is greater than, I flip my sign, 2 divided by negative 2 is 1. All right, so let's take a moment to look at our answers. I have a negative 1 and 1. Okay, so let's take a moment to read this. In case you're confused by compound inequalities, take a moment to write it twice. I have x is greater than 1, and I have negative 1 is greater than or equal to x. We like to see x first. So x is smaller opening, so less than or equal to negative 1. So you have these two statements to graph, in case the one above is kind of tricky looking to you. All right, so I'll do the first one in green. X is less than negative 1, so it's less than. And next I have x is greater than negative 1. Uh-oh, what happened here? So the one with the equal to has a bracket, the one has a parentheses. What happened here? Well, we solved the compound inequality and there's not a point where they overlap. Notice that I had said that make sure that your compound inequalities always point to the left. If they point to the right, not to say they're wrong, it could be true, but you have to be careful. The reason why this one wasn't true is it would have to be so when we write a compound inequality with less than, it's always smaller number and larger. But when they were switched, we still had the smaller number and the larger number in their place. So things didn't transfer over. So our answer for this one was the empty set. And again, this one was a problem because they didn't point to the left, they pointed to the right. Or statements. Definition of a union. The union of two sets A and B is a collection of elements belonging to A and or B. We denote the unions of A and B by, so notice, they overlap. But our answer is what? Our answer is everything. A union is a collection of everything. So you can even think of it as a sum of everything. So when you see a union, a U for union, your answer is everything. Everything that is shaded. All right, let's do an example. Find the union. It's asking for the union, so our answer is those two sets put together. So I have 2, 3, 4, 5, and 7. 2, 3, 4, have 3, 5, and 7. That is my answer. It's everything, not just what overlaps. Definition of disjunction. When two or more sentences are joined by the word or to make a compound sentence, the new sentence is called a disjunction. Definition of or union. The word or corresponds to union and the symbol U. In order for a number to be the solution set of a disjunction, it must be at least one of the following sets of the interval sentences. Note, or statements cannot be combined and written as a compound inequality. So you can't write x with two inequalities. You have to write them separately. That's only for your and statements. Okay, let's continue. Let's do these two examples. So we're asked to graph these two inequalities. All right, let's work each one out. Let's solve for x. Let's get x by itself. So let's move the 7. Minus 7. That gives us 0. That gives us negative 8. So I'm left with 2x is less than negative 8. Divided by 2. Divided by 2. That makes 1. We're left with x is less than negative 4. That's one of my answers. For the next one, I divide by a negative 5. Divide by negative 5. I have x is less than negative 3 over 5. That's one of my answers. Let's go ahead and graph them. So I have negative 4, and I have negative 3 over 5. So it's not even 1. So it's somewhere over here. Negative 3 over 5. Let's graph them. So I'll do my first one in blue. That's saying x is less than negative 4. So it's going to go towards the left. The next one I'll do in green. X is less than or equal to negative 3 over 5. Oh no, I made a big mistake. We divided by a negative, so what should have happened to our inequality? It should have flipped. So that should have been a greater than or equal to. So x is greater than or equal to, so it goes the other way. And our first statement has a parenthesis, the second one has a bracket. All right, so what is our answer? My answer is where they overlap? No, we have an or statement. So my answer is everything. So my answer would be negative infinity to 4 and negative 3 over 5 to infinity. Notice we attach our bracket and parenthesis appropriately. Because we have that break in our answer, and to show that both of them together make our answer, we write a union to symbolize that break. Next example, we have another or statement. So our answer is only where, well, actually it's everything that's being graphed. Let's work it out. So plus 11, that gives me 0, plus 11 gives me 15. 3x is less than 15. Divide by 3, divide by 3, that makes 1. X is less than 15 divided by 3 gives me 5. Alright, next one I want to solve for x. I want to get x by itself, so I need to move that 9. I need to make it 0, so I subtract 9. I have 4x is greater than or equal to negative 8. Next I divide by 4. And I get x is greater than or equal to negative 2. These are my two answers. Let's go ahead and graph them. I have my number line, negative 2 and 5. I'll do the first one in green. X is less than 5. So if it's less than, it moves towards the left. Do the next one in blue. X is greater than negative 2. X is greater than negative 2 with a bracket. So that was a parenthesis and a bracket. So our answer is everything that's shaded. Well, everything is shaded, isn't it? Everything towards the left, everything towards the right. Now I have to be careful with those numbers. Let's take a look at that too. It has a bracket, right? Bracket means that number is included. So that's fine. I don't have to take a break. But at 5, I have a parenthesis. That means not included. So it's every number but 5. So my answer would be negative infinity, and I have to stop at 5 because that number is not included. And then continue from there. So be very careful, keeping in mind where you have an open and a closed interval. All right, now it's up to you to practice these problems in your homework. If you have any questions, you can always email me or use the Ask the Instructor button in your homework. Or you can just watch the video again, see if that makes sense. Or you can also go to tutoring. All right, that's it. Thank you.